Alrighty, here's section 5.3 example 5, I guess. And here they would like to know that if we're told f of x is the function 1/4 x cubed plus x minus 1, and they would like to know what is the derivative of f inverse of x with respect to x at x equals 3. Okay, so oh, I'm sorry, no, A, that's part B, I guess. Okay, part A, they would like to know just what's the value f inverse of 3. So there's part A. Now, in their solution, they say, okay, well, so this function has an inverse, and so for part A, they say, well, because f of x equals 3 when x equals 2, we know that then f inverse of 3 is equal to 2. Or another way to put it is, instead of saying it this way, we just say, well, f of 2 is 3, which then implies that f inverse of 3 is 2, right? We're just reversing the coordinates. Now, here's my issue. How did we know that? Right? They just say, well, because that's true, right? How did we know that? I didn't know that, right? And so I suppose, you know, we could do things like graph this thing. We could go to technology and solve it. We could do some algebra, right? So, but for part A, in essence, I need to either solve very generally. If I first write this as y equal 1/4 x cubed plus x minus 1. So I either need to solve very generally the problem x equals 1/4 y cubed plus y minus 1 for y. Okay, so I could do that very generally, or solve, we know that f of x, we know that x was equal to 3, so solve 3 equals 1/4 y cubed plus y minus 1 for y. Okay, and we could get it that way. So, you know, as I look at that, yeah, it's not real obvious to me. You know, this maybe is something that is, you know, either they did for us already earlier in the chapter, which I don't know that they did, or, you know, something like that. If I'm looking at it, you know, as soon as we get to cubics, there are some ways to try to group things and all that. But yeah, if I'm going to do this, I'd probably start by multiplying everything by 4, and so I would have 4x is equal to y cubed plus 4y minus 4. And then I'd probably kind of move things around a little bit, write it as y cubed plus 4y equals 4x plus 4. So I just move the 4 to the left, but then swap sides of the equation. And now, what this is it's something that looks like y cubed plus, now I could just say an ay and then minus or plus, if I brought that over to make it 0, I'd get a minus, but maybe generically I'd say plus b equals 0. And now I know that has at least one real root that I should be able to find. But yeah, actually, I'm not sure how to do that off the top of my head. Okay, so I'm kind of stuck. So I think, on something like this, I really would probably have to resort to some quick technology to solve that. Okay, and if we solve that, it appears we get 2, and we can check, is it the case that 3 equals 1/4 2 cubed minus, plus 2 minus 1. Well, this is 8 over 4, so I get a 2, and a plus 2 minus 1, so I'll get a plus 1, and that is indeed 3, so that worked. Okay, so to know this thing is not trivial, and I'm not sure why the book made it out like it is. At any rate, so we could use technology maybe to find that, and then B, the derivative. Well, what we know is just that f inverse of x prime is just equal to 1 over f prime of g of x. Okay, so in this case, if I want f inverse of 3, that derivative, that is 1 over f prime of f inverse of 3, or g of 3. Okay, but we're told that's 2, right? So f prime of 2. But again, we had to figure that out somehow, that we could get that 2 there, that g of 3 was 2. And now I do need to take the derivative of f. So I've got f of x is 1/4 x cubed plus x minus 1. So f prime of x is 3/4 x squared plus 1. So that means f prime of 2 is equal to 3/4 times 2 squared plus 1, which gives me 4. And so that tells me that f inverse of 3 prime is equal to that 1 over f prime of g of 3, which is equal to 1 over f prime of 2, but we've just seen that f prime of 2 is 4, so I get 1/4. So there we go. And I could even do a tangent line at this point, because what I know is that g of 3 is equal to 2 and g prime of 3 is equal to 1/4. And so I could do a tangent line y equals g prime of 3 times x minus 3 plus g of 3. And so I get 1/4 times x minus 3 plus 2. So again, if I know all those quantities, I can get the tangent line very easily. All right, so that is example 5.